In this video, we're going to explore how digital technology is changing the way we use and create. We'll explore how digital tools not only simplify our lives, but also expand the boundaries of what's possible in individual areas. We'll break down this concept through three main ideas: basic use, experience enhancement, and innovation creation. Creatively using digital technology can mean different levels of use, from simple everyday actions to innovative and transformative applications. At its most basic, it's about convenience and efficiency, like using a phone to check the news or make online payments. As we move deeper, it becomes about enhancing experiences through immersive tech like VR or smart home, then pushing boundaries to create something entirely new and impactful. Ultimately, creative digital use aims to redefine or even disrupt existing models, driving meaningful change in our interactions, industries, and society. First, let's talk about awareness and the basic use of information literacy. In today's digital world, awareness is more than simply knowing that technology exists. It's about understanding how to effectively interact with it and how to leverage it for personal growth, learning, and advancement. Awareness in the digital age begins with what we call information literacy, which is essentially knowing how to find, analyze, and use digital information responsibly for yourself. Here, I'll use algorithmic recommendations and personalized learning experiences as an example. Algorithmic recommendations on platforms like YouTube, LinkedIn, or Khan Academy are actively influencing how we learn and explore new topics. Algorithms analyze our behavior, what we watch, read, or interact with, and suggest resources to deepen our understanding. This is personalized learning in action. However, these algorithms can also create limitations. They may reinforce existing knowledge, reducing exposure to diverse topics or new learning areas. Additionally, over-reliance on algorithms can lead to a passive learning approach, where users rely heavily on suggestions rather than actively exploring. Balancing algorithmic guidance with personal initiative is essential for well-rounded learning. Another example of this is personalized learning experiences. Digital tools can now be used to customize the learning journey for each individual. Let's take the case of educational apps. These apps use algorithms to gauge a user's learning style, strengths, and weaknesses, tailoring lessons to match their individual pace and preferences. As an example, for those interested in self-learning coding, W3 Schools provides a personalized education experience, enabling learners to progress at their own pace with comprehensive tutorials and practice exercises. The platform allows users to track their progress, revisit difficult topics, and receive feedback, helping to create a customized learning journey that supports mastery of coding fundamentals. In conclusion, personalized learning experiences and algorithmic recommendations represent a significant evolution in the basic use of digital technology. These tools not only simplify the learning process, but also enhance it by tailoring content to individual needs and preferences. Reflective time.
Can you think of other examples of basic uses of digital technology?
Second, let's talk about experience enhancement. In the area of experience enhancement, I will use wearable digital devices as an example. The progress of making chips smaller and faster nowadays made wearable devices more accessible and popular in recent years. Products like AR, VR headsets, smart rings, and smart watches, which were not widely used a decade ago, are now commonplace. Wearable devices can transform our habits into visual data, such as charts and reports, providing feedback and customized health recommendations. Technologies like virtual reality, VR, augmented reality, or AR, and wearable health monitors such as the Apple Watch offer innovative avenues for deeper engagement and personal growth. These tools not only elevate user experiences, but also create interactive environments that foster learning, wellness, and community connection. With devices like Meta Smart Glass and Apple Vision, VR and AR are transforming how we interact with digital content. For instance, in education, immersive VR experiences allow students to explore historical sites or complex scientific concepts in a virtual space, providing a level of engagement that traditional learning methods cannot achieve. Imagine a student using VR to walk through some Hong Kong historical site and event in the past. This immersive learning experience enhances understanding and retention. AR applications further enhance our everyday experiences by overlaying digital information onto the real world. For example, an AR navigation app can guide users through a city by projecting directions onto their view, making exploration more intuitive and interactive. These technologies encourage users to actively engage with their surroundings, transforming ordinary moments into enriched learning experiences. Wearable health monitors, such as the Apple Watch, elevate user experiences by seamlessly integrating health tracking and wellness guidance into daily routines. These devices monitor essential health metrics like heart rate, activity levels, and sleep patterns, while offering real-time feedback and personalized insights. For instance, the Apple Watch reminds users to stand, breathe, and exercise, fostering healthier habits and a greater awareness of well-being. Before the advent of wearable health monitors, recording and tracking physical health advancements was cumbersome and often inaccurate process. Traditional methods relied heavily on periodic checkups, where patients would report their symptoms and health metrics to healthcare providers. This approach had several limitations. First, infrequent monitoring. Health data was only collected during appointments, which led to information gaps and missed opportunities for early intervention. Second, subjective reporting. Patients' recall of their health behaviors and symptoms was sometimes inaccurate, impacting diagnosis and treatment. And third, limited data. Without continuous monitoring, providers lacked a comprehensive view of daily health patterns, making it difficult to detect trends. But now, wearable health monitors have changed the way personal health management is used by enabling real-time data collection. These devices continuously track health metrics, allowing users to monitor trends and receive instant feedback for proactive health management. This empowers individuals to engage actively in their health journey, making informed lifestyle adjustments as needed. Additionally, the integration of health monitoring with social features enables users to connect with friends or participate in fitness challenges, creating a supportive community that makes health management more engaging and less isolating. Finally, we reach a point where technology is used for innovation, which is where creativity meets utility. I will use two ideas in 3D printing as an example, which is transforming concepts and creativity into applications that make a huge improvement in our daily lives. Unlike traditional manufacturing, which often requires large-scale production setups and molds, 3D printing allows for rapid prototyping and customization, opening up possibilities for industries, from healthcare to engineering. Under the area of 3D printing, two key concepts have emerged that are specific to this technology, which is compliant mechanisms and design for additive manufacturing. First, let's start with compliant mechanisms. It is an innovative design approach that utilizes flexible materials to achieve movement and functionality without the need for traditional joints and hinges. One of my favorite examples to explain this concept is one-piece Nerf guns, which are designed to operate efficiently while minimizing the number of separate parts. You may ask, what are the benefits? First, they have fewer parts. These guns incorporate moving elements like triggers and firing mechanisms into a single molded piece, which drastically reduces the number of components compared to traditional Nerf guns that require assembly. Second, this design leads to a lower cost. With fewer parts to manufacture and assemble, production costs decrease significantly, making these toys more affordable. Third, the fewer parts results in a lower weight, making it easier for users to handle and play for extended periods. Fourth, no friction compared to traditional joints, resulting in smoother operation and increased longevity. And last, many of these designs incorporate built-in springs that enhance performance without the need for additional components. By leveraging compliant mechanisms, 3D printing not only achieves a streamlined aesthetic, but also enhances performance and durability compared to traditional models. This innovative approach exemplifies how modern manufacturing techniques can revolutionize toy designs, making them more efficient, cost-effective, and user-friendly. Another concept is design for additive manufacturing, transforms traditional manufacturing by enabling the creation of complex geometries that were previously difficult or impossible to achieve. With 3D printing, parts can be designed as a single unit, reducing the need for multiple components and assembly steps. This not only streamlines production, but also significantly decreases the overall weight of the final product. For example, a fuel nozzle in a jet engine was originally made from 20 different parts, each manufactured separately and then assembled. Using DFAM, they redesigned this component to be 3D printed as a single piece, eliminating the need for assembly and significantly reducing both weight and failure points. By embracing DFAM, industries can achieve greater efficiency, lower costs, and innovative designs that challenge conventional manufacturing methods. Reflective time.
Can you think of other examples of revolutionary changes brought by digital technology?
In conclusion, effectively using technology involves navigating through three key levels: basic use, experience enhancement, and innovation creation. By mastering basic use, individuals can build a solid foundation in digital literacy, enabling them to interact confidently with various tools and platforms. As users progress to experience enhancement, they can leverage technology to enrich their learning and everyday activities, fostering deeper engagement and interactivity. Finally, by focusing on innovation creation, users can explore new possibilities and drive meaningful change. By integrating basic use, experience enhancement, and innovation creation, individuals and organizations can maximize the benefits of technology, ultimately shaping a future that is more efficient, engaging, and innovative.
For additional resources and information, please visit the Digital Competence Education platform